So an object starts at 2 meters per second, and accelerates at 3 meters per second squared while moving 14 meters. How fast is it going afterwards? And I think that might have been confusing because the word rest was in there, but it shouldn't have been. But the problem is if an object starts at 2 meters per second and accelerates at 3 meters per second squared while moving 14 meters, how fast does it go afterwards? So do we have any, what givens do we have for this one?
Initial velocity?
Right, we have initial velocity, and what's that going to be?
2 meters per second.
2 meters per second, right? That's the speed that we're starting at. That's our VXI. Good. So put the paper up. Okay. What other givens do we have?
We have acceleration.
Right, we have the acceleration. Thanks, Siham. What's the acceleration?
3 meters per second squared.
Yeah, 3 meters per second squared, right? We know that's the AX, the acceleration. We're sure about that because of the unit, right? Meters per second squared is always going to be our acceleration. And then what's the other given that we have today?
And distance, 14 meters.
Yeah, and the distance is 14 meters, right? That's how far it goes. Good, so we've got 3 givens, so that should be enough. And then the unknown, which quantity are we being asked about?
Final velocity.
Final velocity, yeah, how fast is it going afterwards, right? So we're looking for final velocity. So we've got VXI, we've got AX, delta X, and VXF. So which of our kinematics equations could we use to solve this problem?
The last one.
Yeah, that's right. The last one, right? The last one has those quantities, VXI, VXF, AX, delta X. And that's the only one with those exact quantities, so we'll copy that down. Final velocity squared equals initial velocity squared plus 2 times acceleration times displacement. And let's see, we don't need to rearrange today, right? Because the final velocity is already all by itself on one side of this equation. So we can go right ahead and plug in our numbers. So our initial velocity was 2 meters per second. We have to square that. Then plus 2 times our acceleration, 3 meters per second squared, times the displacement, which was 14 meters. So that means my final velocity squared is 2 squared plus 2 times 3 times 14. So that's 88. And the units for that, we have meters over seconds and it's squared. So it's meters squared over seconds squared, which should remind us that we're not quite done yet, right? This isn't our final velocity. This is the final velocity squared. So what's the very last thing I need to do in order to get the right answer for final velocity?
You have to square root the whole thing?
Exactly. We have to square root the whole thing, right? Because if I square root this side, then I just get final velocity.
And what you do to one side, you have to do to the other.
Exactly, always, right? Whatever we do to one side, we do to the other. So square root of 88, 9.38. And if I take the square root of meters squared over seconds squared, I just get meters over seconds. And that's the unit for velocity, so it seems like we did the units right. And 9.3 meters per second, that seems like an okay speed for if you started at 2 meters a second and accelerated for a while. Okay, anybody have